Hello everyone. Now I'm going to explain the third problem, which is implementing a stack using two queues. First method is to making the push operation costly, and the second is making the pop operation costly. In the first method, first we enqueue the x, which is the new element to be added to the stack. We will enqueue it into the next queue, which is q2. So this 5 will come here. So or 5 will come here, and then we will pop all the if there are any elements in this q1, they will be copied to q2, and after that we will rename this q2 to q1. Then for the next element 4, first we will add this 4 to q2. We are renaming, means this is empty now, and there we will add the 4 here first, and 5 is already here. Then we will dequeue these elements and we will add to the or enqueue to this, so 5 will be copied here, and then after that we will rename it again, and this will be dequeued, means this queue is empty and this is q2 now. For the third element, so now the 3 will be down, 4 will be up, on top of that 4 will be added, and then 5 will be added. So whenever you want to dequeue from this queue, you just dequeue and you will get the latest element which is added to the stack, which is 3. So this operation, for this push operation, is costly, which time complexity is order of n, and the pop operation is less, order of 1. So the implementation is like this. I will show you. So this is like push, pop. I'll just directly go to the, so there are two queues, q1 and q2, and then the stack's current size is, if it is 0, first it is 0, and then we are pushing the elements, this is the function for that. Then we are popping the elements, this is the function for that. And then so for this we are implementing the queue stack using the using two queues. So if the current we are going to increment the current size as we are adding the elements to this, in this q2 dot nqx. So in the second queue we are adding the element which needed to add to stack, and then we are going to, while the q1 dot count, means while the first queue is empty, we are going to dequeue this or dequeue the queue, and then we are going to enqueue those, or we are going to copy all the elements from q1 to q2 in simple terms, and then we are going to swap the names of the queues using this. We are using this queue as a temporary queue variable, and then the pop operation is just like we are going to dequeue the, if there are no elements in this first queue, then we are going to give the error, or the queue is empty, or else q1 dot dequeue should give us the latest element which is entered in the stack, and that is the pop operation. And then so the time complexity is order of n for push and order of 1 for pop. Now the second method is pop operation is costly and push operation is not costly. So in push operation we are just adding the elements in the queue as if we are enqueuing the elements, and for while popping the elements for the stack, that means we need to get the latest element which is entered as 7, should be we should be able to show it, or we should be able to display it. In that case, we are going to dequeue all the elements from this q1 to q2. So the elements which are added in this queue are 5, 4, 3, 2, 7. So we accept the last one. So we will dequeue these elements and enqueue in this. So the elements will be stored 5, 4, 3, 2, and we will, the last element we will dequeue, and that will be your pop operation of the stack, and for this we will need the time complexity of order of n, and for push we are just adding the elements on top of the queue, or we are enqueuing the elements, so it is only order of one operation. So the second implementation of this is, the second method of implementing a stack using two queues is where pop operation is costly. So here there are two queues, then this push operation is just simply add the q1 dot nq, which is just adding the element to the q1, that is the first queue, and the pop operation is costly, where if there are no elements in the first queue, then the element, then q1 dot count, if it is greater than 1, then q2 dot nq. So we are going to dequeue all the elements in q1, and we will add to or nq to those all those elements to q2, and then so those elements except the first one, where which is that's why we have this greater than 1. So the first element is stored in this integer q in this variable res, and then so this temporary variable is going to store the first element element in the q1. No, this is for swapping the names of the queues, and we are returning the this one, which is the last element of the queue. I think I confused you, but here in this this thing